Okay, so in last session, we have seen some robot and simulation, right? We have started with Husky, then we have discussed Turtlebot 3, which is an educational robot. Now we are going to discuss some robotic arms. So we will be seeing two robotic arms. One is universal robotic arm, also called UR5, or I mean UR, okay, and another robot is XARM, okay, which is actually a Chinese company, which is from a Chinese company. It's called U Factory. So this is a robot. So we are going to see the simulation of these two. Okay. So first, let's start with the universal robot, which is a very popular semi-industrial robotic arm, which is having 6 degree of freedom, I think. Reach is about like 1.75 meters, and this is the latest one. So based on the payload of the robot, there are different types of robot. Like UR3 means you are robot with 3 kg payload. So the payload means the weight it can take, the gripper can take, okay, the end effector can take. This is the latest one, that is UR20. So yeah. So in order to get the simulation, you can simply search for like universal robotic arm gazebo simulation. So you will get official tutorials from ROS Wiki. So this is one of the official stack of universal robot. So you can anyway like control universal robots from gazebo, and also there is an official ROS driver to control the hardware. Okay, so and this is actually available in the Synaptic Package Manager, okay, in the app packages. So in order to install UR5, what you have to do is simply go to Synaptic and search for UR gazebo. You can search. Seems like it is not listing. If it is not officially available, I mean, if the binaries are not available, we have to clone. Yeah, I think yeah, the binaries are not available. So what we can do is we can go to the repository of universal robot. So this is the GitHub repository for universal robot. It is having simulations, then drivers means that package. No, this package is having nodes, ROS nodes, to communicate with the universal robotic arm. Okay, and also there is a moveit config. So moveit is actually a ROS based framework for manipulation, okay, robotic manipulation, that is pick and place and all kind of application. Okay, so like navigation stack for the wheel robot, we have moveit for the robotic arm. So if you simply search for moveit ROS, you can see the motion planning framework. I think I have shown you before. So moveit is available in ROS 1 and ROS 2. So the same thing we can see in ROS 2. Okay, yes, yeah. So that is a thing. So what we are doing is we are trying to set up the packages. So these guys are saying like it is supported. The binaries are available in 16.04. Maybe we can have a try with this command. Let's see this command will work or not. No, it is not working. So then we have an option, that is a building from source, meaning we have to clone the packages and then do the cat can make, and then yeah, the same step that we are doing. So here we are going to clone the packages and build it. So maybe I can just clone everything into this workspace. Okay, you can create another workspace, so you can create any number of workspace. Okay, any number of workspace is possible. After creating any workspace, you have to source it. So this is how we are sourcing it. So there is a folder inside the workspace called devel. Okay, inside that there is a setup.bash. Okay, so you have to source this bash file. Sourcing means simply run the bash file. Okay, bash file means it's a shell script, and when you source, the environmental variable and all the variable will be available in this terminal. Okay, so this is the thing that you have to do when you create a new workspace. And if you can add this line in the .bash rc, then it will be automatically sourced. Okay, so you can see I have added the sourcing in the .bash rc. Okay, so currently I am in src folder, and what I am doing is I am just cloning it. Okay, so okay, so seems like cloning universal fatal remote brand noitic devil not found. It is complaining about there is no noitic branch found. Okay, so we can just check what are the branches. So there is kinetic devil, there is melodic devil. So what we can do is we can just try the melodic. Okay, melodic was a previous version of ROS. So just try with melodic, and some packages will work in noitic. I mean, even if the code is tested in melodic, some packages will work in noitic, but it is not guaranteed. Okay, so we can have a try. Let's see. Yeah, it's actually cloned. It seems like it's cloned. And so after that we have to do the Gatkin make. Okay, let's see whether it will compile or build or something. And for the exam also, if you just search for exam ROS GitHub, you can able to find exam repository, and it is also the ROS 2 version is also available. So this is the exam, and they have also a good documentation for setting up these packages. Okay, yes, yeah, it is complaining about move it. Okay, so these packages, when we build these packages, it is complaining that there is a package called move it core. Okay, that is not found. So what you can do is you can simply go to Synaptic Package Manager and then search for move it core. So just remember, like move it, instead of move it core, just use move it core. Okay, move it -core. And yeah, so we could able to find the move it core package, double click it, mark it, and install. Okay, so this is one dependency that these packages required. So if you are getting this kind of error, then just extract the package name. This is a package name, or you can find the package name from here, move it core. Okay, so move it _core is a package name, but in order to get the binary, it will be like move it -core. Okay, okay, so let's see whether, yeah, it's installing. Okay, I think we have successfully installed the move it core. Okay, and now I'm doing the Gatkin make again. Okay, it's building. Okay, so it's complaining about move it kinematics, that is not available. So again, just go to the Synaptic, search for movie kinematics. Yes, that is available. So double click it, install, apply. Let's wait for some time. Okay. So after that, we can build it again. So this is how we are fixing the dependency, guys. Like if you build a package or something, if it is complaining about some dependencies, I think you can first search for that package in Synaptic. If that is not found, you can search in Google and you can find it in GitHub, maybe that package. And that package you can clone it to your ROS workspace and then build it. Okay. Okay, let's try whether it will build or not. Okay. Yeah, it is building. We don't know like if there is any error happening at the end. So far, good. These all are like not errors, it's most warnings. Yeah. Okay, great. So I think we could able to successfully build the packages. Okay, great. And now we can able to launch the simulation. So we have the UR gazebo package, which is a main simulation package. So just do rho cd UR gazebo. So it is actually pointing to the package that we have cloned. Great. And now just do UR gazebo. So don't confuse, guys. So the use of rho cd is to find whether it is detecting the package or not. Okay, so that is not mandatory, but it will be great if we can find it, so we can confirm it that package is built properly and it is visible. So after making it visible, just use the command ROS launch UR underscore gazebo. So I think there is UR turn, so we can start the UR turn robot. Let's see the simulation of UR turn. Okay, yes. Okay, so this is the simulation of UR10, Universal Robot Arm 10. Okay. Okay, so so how can we interact with this robot? So mostly if you check the ROS topic list, you can find some controllers assigned to it. Okay, and these controllers, the type of controllers that is currently assigned to UR5 is called trajectory controllers. Okay, you can read that name, arm controller / follow joint trajectory. Okay, so if you search for follow joint trajectory, what you can find is like the follow joint trajectory in ROS basically using for sending a trajectory. Okay, trajectory means a group of points, group of values for each joints. Okay, so when you send one trajectory message, it is having necessary information about the joint. Okay, not only single joint, all the joints. Okay, with the timestamp. So in 1 second the joint value will be this, and in the next second the joint value will be this, something kind of, so you can find the follow joint trajectory. It's actually a ROS action. Okay, so we are basically like sending a trajectory data. These are the goal, okay, and these are the feedback, and these are the results. Okay, so we are basically using the follow join trajectory controller. So why we are using this? Because in order to interface the simulation into MoveIt, okay, MoveIt is like a higher level motion planning framework. We need this controller, okay, follow join trajectory controller, because MoveIt is acting as a ROS action client. Okay, so we are configuring Gazebo as a join trajectory control server, okay, like an ROS action server, and the MoveIt will be acting as a ROS action client. Okay, so the MoveIt configuration is actually there. So I'm actually showing for a demo. Okay, I will explain about MoveIt later. So if you just search for UR10 MoveIt config, okay, so this is what the configuration means. This is actually a package, okay, and we can actually generate a config package for our own robot. Okay, if you have a custom robotic arm, you can create a config package which is having the inverse kinematic solution, then planners, so like the navigation stack. Okay, so you can add the high level stuff for doing the motion planning. Okay, so in order to do the motion planning, I can show you that the instructions, I think, is there. The simulation instruction is also here for the Gazebo simulation. Okay, okay, so MoveIt motion planning. Okay, UR10. Okay, oh wait, sim equal to true. Okay, there is an error. MoveIt ROS move group. Okay, let me check. Let me first close the simulation and search for ROS Noitic MoveIt and install all the packages. Okay, so I think we didn't install all the packages of MoveIt. MoveIt is having a lot of packages, so it will be better to install all these packages, like yeah, we can just find ROS Noitic MoveIt packages. You can just ignore the DB packages, which is a debug, so that is not important. Rest of the packages you can install. Okay, MoveIt core. So let me install all this. So even when you set up the packages on your computer, it will ask for the dependency. Okay, so this is how we can install. Just wait. Okay, so that is the error that we are getting. It is not finding MoveIt move group or something. Let's see, that is the actual reason. Okay, now let me start the simulation. Okay, so the robot is ready in the simulation. So if we have the real robot, we have to switch on the robot and start the driver. Yeah, now I think it is okay. So the dependency is working. Now let me start the visualization. So basically, yesterday we have seen the path planning of the robot, of the wheel robot in RVs, right? So similar to that, in order to motion plan the robotic arm, we are actually using RVs. Okay, so there is a plugin called motion planning plugin. Okay, so you can simply place the end effector in one. Like placing the end effector means we are actually setting the goal position of the robotic arm. Okay, goal position is actually the tip of the robotic arm. So this is the default position of the robotic arm. It's actually like laying parallel to the floor, and we are setting the goal position. Okay, so robot has to reach here. Okay, so that is our goal. Now yeah, so we have set that goal. Okay, so now there are some options here on the left in order to plan a path from the current position to the goal position. So you can see it is planning a path. Just watch closely. You can see it is planning a path and reaching that. Okay, so the planning is done, and there is an option called plan and execute. Okay, so what happening is that when you press that plan and execute, it will first create a plan and then it will execute it. Execute means the move it is creating the trajectory. So basically we have the gazebo, right? Gazebo or the actual robot. This is acting as a ROS action server, and the move it plugin and the underlying nodes acting as a client. So when you press the plan and execute, the client will be sending the trajectory into the server. Okay, meaning it is sending the trajectory into the gazebo. So what will happen to the gazebo? Gazebo will move like the planned path. So if I press plan and execute, you can see it's slowly executing the trajectory. Okay, if it is a real robot, it will move like this. Okay, so so that is how the motion planning of the robotic arm is doing. And the advantage of having a simulation of a robotic arm is that we can do a lot of experiments. You don't need the real robotic arm, because you know this robotic arm is actually costing around 25 lakh to 30 lakh. Okay, I mean that's actually a range. It is more than that. Okay, for the UR20 it is actually more than that. So in order to play with, or in order to work with, experiment with this kind of high-end robotic arm, I think the simulation is actually a better choice. So you can create an application using the simulation, and then later you can put it in the real hardware and it will work similar to that. Okay, so if I'm putting the goal position here and if I press plan and execute, you can see the robot is working based on the planning. Okay, and you can I mean the robot may hit to the ground. Okay, that can happen if the planning is not correct. And also I think we can stop the plan. Yeah, we can stop the plan as well, and we can set some random goal position. Yeah, so actually look at this plan. Okay, look at this plan. The plan is actually below the floor. Okay, below the floor. Okay, and if you execute it, if it is a real robot or simulated robot, it will hit the floor, right? So I just want to show you that scenario. So plan and execute. So let's see what happened. Okay, so the robot is hitting the floor. It got damaged. Okay, and it's acting weirdly. Okay, got it? Yeah, so these kind of situation we can simulate it, okay, in this in using Gazebo. Got it? Yeah, so I just want to show you this the manipulation. And okay, so now I can just move to the next simulation, which is X-arm. Okay, the same thing, like the same robotic arm, similar to UR5. The advantage of X-arm, I think, is mainly on the costing. Okay, it's much cheaper than I think it's 10 less than 10 lakh or something. Okay, much cheaper compared to UR5. So it's like a cobord, and there are different series of X-arm. So you can see starting from $3,000, and there is $5,500. So it's less than 10 lakh. Okay, so we are going to see the setting up of X-arm simulation. Okay, if we have the hardware, then that instruction is also there, how to set up the yeah. So now we are just cloning this repository. Okay, so just copy paste into our repository. Okay, so it is cloning all the packages. I think it's a bigger one, in the sense it is having a lot of package. Now they are asking to execute these commands to update. Okay, so we can simply update it. So the command is like, just go to X-arm ROS and then just copy paste git pull. Okay, git pull. Okay, let me do git pull. Seems like it's already updated. And then git sub module sync. Okay, yeah, that is done. And then yeah, this one. Okay, done. Okay, so now they are having some commands for installing the dependency. Okay, so this is one command, useful command, that we can use for installing the dependency of the packages. Okay, I think there are some issue with this. The ROS dep, we have to install it, but if you install, maybe, I don't know, like, let me see. So if you are trying to install a command from command line, make sure the GUI is closed. Yeah, so there is a big risk, guys. So if you install these packages, the ROS packages will be uninstalled. Okay, so just cancel it. And one thing we can do is we can simply build it. Okay, and then install the dependency. So for now we are leaving that option. Yeah, so just build the packages using catkin make, and let's see what will happen. Okay, it's building. Seems like it's building properly. So there are many packages, that's why it's taking a lot of time. Okay, so in the meantime we can check the instructions for running the simulation. Okay, yeah, I think they have already mentioned some commands and all to run the simulation. Okay, so maybe we can do this demo. If no exam gripper needed. Okay, we can try a demo. There are many options like with gripper, without gripper. Yeah, this is nice. So we are first trying to do this simulation. Okay, so you can see the robot is actually mounted in a table. Yes. Okay, so this is our robot, and there is a table and which is mounted on the top of the table. Okay, so now this is actually configured for working with MoveIt. Okay, so you can simply check it. Okay, see the trajectory controller, follow joint trajectory, so it is actually configured for the trajectory controller. And now we are starting the MoveIt config. Okay, yes, so this is the MoveIt config, guys. So I can show you side by side. Okay, right, now the simulation. Okay, right, so now the thing is simple. Just give a goal position. I'm just giving this goal position and then do the plan. Okay, we have seen the plan. Now the plan and execute. So you can see the robot is moving to that position. Okay, okay, so through this you can easily implement some kind of like pick and place. I will not say this kind of planning is pretty accurate, but we can able to like fine tune these motion planning inverse kinematic solver parameters, so it will work. I mean, yeah, it will work good. Okay, but I'm still have doubts regarding the repeatability. Like the IK solution will not be available in all the positions. Yeah. Yeah. Yeah, now you can see it is it is actually uh, hit the table and it fell down. Okay, the robot is actually fell down. So you can check like yeah, it's actually fell down. So the controller can't able to execute, is actually failed. Okay, yeah, so I think these are some simulation I just want to show you. And let me see sport mini gazebo. So if you are interested in simulating the quadruped robots, I think the simulations are available. Okay, so you can try that. Not this, there are different simulations available. So in most of the robot, yeah, champ, if you check this repository, you can see the simulation of a different quadruped robots. Maybe I can share it. So the instruction for setting the simulation is also mentioned. So the supported robot, yeah, so these are the supported robots. So these are some of the popular quadruped robots: Animal, then Champ. I mean, this is a Spot Mini, and this, I think this is from another company. So all these robots are like are available as a product. Okay, yeah. Okay, yes. So I think we have discussed some of the basics, simulation robot model. Just okay. So we have seen some basic simulation. So what you have to do is, when you get time, just go through these simulations, and you will get an idea. Like if you take the repositories, you can see the gazebo folder, and just go through it. Like it's mostly the same actually. Okay, so you can see it is loading the controllers, then spawning the models, control manager. I mean the same thing. Okay, but in a putting it in a different way. But basically it's all like loading the robot description, spawning into gazebo, loading the controller, control manager. Yes. Okay, so these are the main things. So you can just go through it. Okay. Yes, I think that is some part of the some part of this some part of the topics from this chapter, but we didn't completed it yet. We have one section remaining, that is creating simulation packages from Fusion 360. That is actually pending, and this thing maybe I can show it now. This is actually a small project that is done by my course member in my first course. So I can just share that. After that, I think we can start with this chapter. Okay, I can give you some idea. So let me show you the jetboard. So I think you may heard about the jetboard robot. Note this. So jetboard is from NVIDIA. Okay, it's a DIY kit from NVIDIA. Mainly it is having a Jetson Nano board. Okay, and it is having basic like two-wheel robot. It's a basic two-wheel robot, and it is having a camera on the front. And yeah, so that is a very basic robot. Okay, and so this guy, the guy I mentioned, he actually created a simulation for jetboard. Okay, so maybe I can show you that. Okay, just a second, let me just switch my GitHub repository to Robo Academy. Yeah, so I think he is there in the course. Just a second. In the collaborators, I think I can find him. Yeah, so he's interested in this course as well, so he joined. So this is the repository, I mean his profile, and these all are the things that he created. I mean, these are all the things we create as a part of the course, and some of the projects. So let me show you the jetboard simulation. Okay, yeah, jetboard perception, messages. Yeah. Okay, maybe I can simply search for jetboard drift drive, slam, jetboard gazebo. Okay, so he actually done everything as a single repository, and that is not required. Basically we can create a single repository for all these things. Okay, yeah, I think this package will work. So in this repository he actually put all the packages for gazebo and everything, and these are some of the images of the simulation. So in this simulation, in this robot, he added an RGB camera, then a RealSense camera, RP LiDAR, 8 sonars, 1 GPS, IMU, and the differential drive plugin. Okay, so this much of sensors, and he documented it well. Okay, I don't know it will work or not, but let let me have a try. Okay, so we can simply follow the instructions that he have created. So let me go to the workspace src folder and cloning the repository. Okay, and then yeah, let me check. Okay, Hector Gazebo plugins. Yeah, that is already in my system. And RealSense Gazebo plugin. Let me check. RealSense 2. Okay, it's not there. So I'm just cloning the next package, and I think this package is available in my PC. Now I'm doing the Catkin workspace. Let me see what will happen. Okay, there is an error. Okay, let me see. Jetbot desktop robot simulation. Okay, I think I need some modification. Jetbot, then simulator robot. Let me build again. Okay, jetbot.vis.config. So there is another package missing, that is jetbot.vis. Let me check that is available or not. Yeah, this one. So let me clone this package as well into the src. Okay, done. Now doing the Catkin make. Oh, okay, so it's complaining about jetbot diff drive. Okay, wait, maybe I can delete this. Oh, it's again complaining for jetbot vis. Okay, jetbot navigation, right? So currently I think we don't need the navigation, so that delete it, and let's build again. Oh, the next package, the drive teleoptis keyboard. Okay, we can delete that for now. Yeah, let's me build again. Okay, now I think it's building. Oh, again jetbot slam. Okay. So it's required cartographer. Okay, let's just delete it. We just need the simulation and the control. Seems like, oh, okay. Yeah, I think there are a lot of dependency issues. There is an issue with the RealSense. So let me delete that plugin. So actually the organization of this repository is little, I mean, I'm not recommending it, because what he did was he created a repository and then he include all these packages as submodules. That is okay, but we can, I mean, maintain all this package in a single repository. That is actually more flexible, I will say. And here he mentioned he's actually taking the structure of Husky, Turtlebot 3. Yeah, that is okay. That is okay. So when you do the project, I mean, you can refer one of the project like Husky or Turtlebot 3 or anything, standard projects available. Seems like it's built. And now let me start the simulation. So first let me try to check that package is visible. So the package name, what was the package name? Jetboard Gazebo, right? Yeah. CD. Okay, yeah, seems like the package is detecting. Now let me start some launch file from the Jetboard Gazebo package. So it will show the okay. Some error mainly because of the plugins. Oh, okay. Oh, got it. Yeah, previously, like, the simulation was there, we didn't close that previous simulation. So let me close this stuff, and this simulation was already working, so that's why I just want to exit this. Oh, okay, let me start it again. Okay, right. Okay, so we can see the robot is here. Okay, it's a simple robot, but it is having it is loaded with lot of sensors. Okay, so the advantage is that, I mean, the thing actually done for learning purpose. Okay, so you can see it is having lidars, then the sonars, I mean, that is ultrasonic, and he's using the Turtlebot 3 world. Okay, so simply you can drive the robot. Just check the topics. Just a second. ROS topic list. For command velocity, we have what? Okay. Let me search for CMD well. Okay, so seems like okay, I need to load the controllers, I guess. That may be the reason. Currently it is loaded the sensors and all. So now let me load the controllers. Yeah, nothing in the controller. Yeah, I think Jetboard. Let me check the control package, and we have the launch file, and there is a control.launch. Seems like it will start. Okay. So this package will launch everything, okay, with the control, so that we can move the robot. So let me start this launch file. So because for differential drive, he's using the differential drive controller. Okay, so we need to load that controller, and yeah, so this launch file, that is ROS launch jetboard underscore control.launch, will launch everything: simulation, controllers, and the RQT steering plugin. Okay, it will also load the visualization. That is pretty good. Great. Yeah, so we have the simulation, we have the visualization of the robot. Okay, the sensor values are not visualized. Then we have the steering plugin. So just try to move the robot using the steering plugin. Just check whether it's working or not. Yeah, I think it's moving. You can see the robot. Oh, it will hit. Oh, it's actually hit the floor. Yeah, let me move back. Yeah, it's moving. Okay, great. Okay, so we can able to move the robot, rotate the robot using the joystick. And now in order to visualize the data, I think you can able to visualize it very easily. Like choose by topic, and then you can add the laser scan. So this is the laser scan data. So this is the laser scan data coming from the robot. And then we have other sensors like IMU. So this is the arrow from the IMU. Okay, so we can disable it for now. And then we have the camera, then the sonar. Okay, just a second. You can see the sonar sensor. Okay, so this is the data coming from the sonar. So if you simply rotate the robot, you can see the sonar values is also changing. Okay, just make this as auto, as a base footprint instead of base footprint. Simply rotate the robot. So you can see it is the sonar is detecting an obstacle, and so the range will be shorter. See, so there are 6 sonar or something. Okay, so you can add sonars like this. Okay, I'm adding like 3 for now. Okay, and now what are the other sensor? Yeah, there is a depth camera. So it is it can provide you with point cloud and the image. Okay, so for now I'm just disabling this because the point cloud data is actually taking a lot of computation. So for now I'm just deleting the laser scan and now adding the point cloud. So let me see whether it will work or not. I think it will not work properly because of some sensor issues. Let me try again. I'm just adding the point cloud 2, which is the type that we require, and then check for the topic if there is any point cloud 2. Okay, there is no. But let me try to add the camera. Yeah, camera is working actually. So if you can see the robot, in front of the robot there is a camera, and when the robot moves or rotate, you can see the camera view of the robot. Camera view is this. Okay, so the camera is working. Just a second. Okay, now what are the other stuff in the robot? Yeah, so here is the TF of the robot. Just a second, let me stop it. Okay, yeah, so let me stop this, otherwise it will hang the system. So that is actually the JetBot robot. So there was no simulation for that robot, but he created a new simulation as a project. Okay, so this is his his project actually. Okay, so he made this project open source, and yeah, there are a lot of explanation for it as well. Okay, so he created a lot of videos and some tutorial as well. This is his channel.
For example, this.
Okay, anyway. Okay, so that is the JetBot simulation. You can able to see the code from his repository. Okay, so let me share the exact link. JetBot diff drive. This one. Okay, so from that, just take the description package, then simulator and the control. Okay, so this is what the project is about. Okay, one of the project that done by my previous course member. Okay, so tomorrow I think we can start with this this chapter. Okay, so we will be like talking about the autonomous mobile robot. Okay, so after completing this chapter, we can work on like simulation based project. So I am looking for projects in wheeled robots, then robotic arm, quadruped robots, and it's your choice. Okay, so you can decide, and we need to create some projects for the portfolio, for your portfolio. So yeah, so tomorrow and day after that possibly we will be like discussing the autonomous mobile robot. Okay, where are we using the autonomous mobile robot, the application, and an abstract idea about the ROS navigation stack and mapping, localization, all the stuff. Okay, so now it's a time for question. I know like we have simply discussed about some simulation example. So if you have any example, if you have any questions, please let me know. We can discuss. Time for questions.
Great, Professor. So,
Can you
uh,
repeat? Yeah.
yes, sir. So actually, I just recently changed laptops.
Okay.
I installed ROS on WSL, which is Windows Subsystem for
Yeah.
Linux, which doesn't need a VMware or a separate Ubuntu
Yeah.
installation. So I was running into one problem, which is that I think we need to change the shebang in the CMake files to like support Python 3 instead of Python. I'm getting stuck how to fix that.
Yeah. So shebang in the not in the CMake, I think in the Python file, right?
Yeah, because like I'm getting the error Python command not found.
Yeah. So
Like Python no such file or
yeah,
directory.
so that shebang, no, the shebang that we are using in Ubuntu is slash user bin Python. It may be different for Windows. Okay, and in Windows, I don't know, like we need the shebang. So you can check like if the default Python version is Python 3, then do we really need like the shebang for Windows? Okay.
Actually, it's not installing on Windows. Like it's a complete Ubuntu on top
Yeah,
of
yeah,
Windows.
WSL, right? Yeah, I know. Yeah,
Yeah.
yeah, yeah. Yeah, so just check, like we can simply check it. Like if you have the shell environment, then you can simply check user bin and then just check for Python. Uh,
Okay.
just check for Python, just a second. So here you can see that there is a Python 3, right? So
Yes.
yeah, so like that you can check it, and then if there is any Python 3, I think you can put slash user bin Python 3.
Okay, I have gone to the bin. I'm checking if there's a Python.
Yeah, yeah.
That's a lot of files.
Yeah, the thing is that I'm not pretty sure about the WSL stability as well. Yeah, it's actually I mean built on top of Windows, but I don't know like how stable it is, all this stuff. But if we want the complete isolation, I think VMware or VirtualBox, and it's also completely portable. Like if you want to like move the entire system into another system, or like if if you are making a mistake, for example, if you are uninstalling a package and something, if something went wrong, if it is VMware, then that will not directly affect the real operating system. But if you are using WSL, it's actually the part of the actual operating system, right? So I don't
Yes,
know
sir.
like how it will affect the actual OS, because one of our objective is like while learning we may make mistake, right? So in order to
Yes, sir.
in order to I mean, in order to not affect the actual PC and also the OS, we are using VMware. But if we are like confident in WSL, it's not a problem. And in real Ubuntu means Ubuntu installed on real PC. That is also fine. So while I think while working with ROS2, I think it can work without WSL, I guess. It is compatible with Mac, then Windows, and Ubuntu. Okay, so
Okay, ROS 2 they are making compatible with Windows
yeah,
as
yeah, it's a
well.
cross-platform.
And so yeah, there's Python 2, Python 2.7, and Python 3. Wait, which was it? Python 3.8, yeah. So I have these three packages.
Yeah, yeah. So you can just maybe you can just. Is there any Python 3?
Yes, sir, Python 3.8.
Okay, then try with Python 3.8. Let's see if there is any change. Otherwise, I will check it. Okay, I will check and
Yeah, actually, I was trying to run the total sim demo, but that's where I'm getting the error.
yeah. I mean the Turtle Sim is working, right? Turtle Sim is actually working. That node is actually working, right?
I'll share my screen, sir, if
Maybe
that's
I think
fine.
maybe we can do it after the call then. I mean after the session.
Okay, sure, sir.
Okay, if it
Okay,
is
sure, sir.
taking time, maybe we can
Yes, sir.
discuss it. Yeah.
Yeah.
Yeah, yeah. So yeah,
Sir,
yeah, Kalpesh.
sir, when is cross perception going to be included?
Yeah, so the perception and the embedded, it's actually after the project that I am planning. So
Okay, sir.
okay, so the perception is mainly having two main topics, OpenCV and PCL. And after that, we will see YOLO object detection and 3D object detection. Uh, yeah, so these are the topics that we are planning. So initially, we have to build some projects. This was one of my plan, like do some projects using basics of ROS, then do some projects using Turtle simulation, and do some projects on Gazebo, then robotica. I mean, using Gazebo, we can build wheeled robots. Uh, I mean, the robotic arm, any kind of robot. Then after that, we can build some autonomous. We can make a wheeled robot into autonomous. Okay, so in each phase, if we can able to like create some projects, then you are learning it. Okay, so it's not about like learning all this stuff. It's all about like implementing, right? So then only we can actually put it. The fundamental idea is like creating a portfolio like this. Maybe I can show you the previous course member. So like you have to make your GitHub like a portfolio, like a presentation. Like you can simply you are going to share the GitHub link in the CV. or like if you're going for masters, or if you're planning to get a job, or if you're a student, anyway you will have a CV, right? So this should be one thing. Okay, so you have to make the GitHub, I will say very beautifully. You have to create a a nice readme, and also all this portfolio should be pinned in. Okay, it should be in the front page, so then people can access your projects and then evaluate you. Okay, so that is actually the idea. Yeah, Kalpesh. Yes. Any more questions? Okay. So if you don't have any question, I think we can conclude. And then Archit, you can stay. Yeah. So tomorrow, I think we can start discussing the chapter building cheapest autonomous mobile robot using ROS. That is the next topic that we are planning to discuss. So see you tomorrow, guys. I think other than Archit, others can just leave, and then we will discuss. Okay. Thank you, guys. Thanks for attending. Good night.